So the rest of the semester, the last 3 days of notes that we have are going to focus on how growth happens. We're going to focus today on how things that are alive grow. So we're going to talk about people and animals and bacteria and virus and things that are living, how they grow. And then next week we'll talk about money and how money grows or shrinks in either case. But we're going to start with living things today. Okay, here's the formula for how something grows. P equals. You start with P, we call that P sub 0. It's the original size. It's how big it was at the beginning, at the start. We call it initial population, the initial size. Parentheses, 1 plus or minus R. Okay. R is the growth rate. If it's a plus R, then it's growing. And if it's a minus R, it's not growing. So the opposite of that we say is decay or shrink. And then we have T, which stands for time, and K. So let's figure out what all these letters stand for. All right, so I've told you already that P sub 0 is the initial population. So that's how large something is at the beginning. R is the growth rate or decay rate, depending on if that's a positive or a negative number. So it's the growth or decay rate. All right, T is time. Okay, that's pretty typical. And then K. K is the growth cycle length. So for example, it says that this is happening once per month. Well, then the word once means that the K value is 1. If it says it's happening twice per month, then the K value is going to be 2. If it says it's happening every 6 months, then the K is 6. Like it's how often that this cycle is happening of the growth. Okay. If it takes 20 days to do this, that's the length of the cycle. Whatever units. So yeah, if the T, the time, is measured in days, then the K would be measured in days. If the T is...
It would be like days, and then like it happens every 6 hours.
Oh, you know where they mix them? Sometimes then you've got to adjust it to make sure that they match. Right, you do that in chemistry, right? Make sure your units match and stuff? But you were. Yeah, all right, let's try a couple examples. All right, so let's talk about population. Let's talk about San Jose and Detroit. Okay, yeah, very different, very good. All right, so San Jose, a model for the population in San Jose is 898, 759. Parentheses, 1 plus 0.0064 to the T. And then Detroit, P equals 1 comma 203 comma 368, followed by the parentheses 0.9858, also to the T. Oh, no K's? There's a K. What does the K happen to be? It's 1. Okay, so the K is, there's always a K, but the K is 1, so the cycle length is 1. Okay, perfect. That's actually an awesome example. What can you tell me just by looking at this? Okay, so somebody tell me a fact by looking at these equations. Okay, Daniel.
San Jose is growing, Detroit is decaying.
How can you tell that?
Because the number in Detroit, or San Jose, in parentheses, is greater than 1, and in Detroit Detroit less than
Exactly. Okay, so he can tell that San Jose is a growing city where Detroit is a shrinking city, and that's very true. Okay, both of those cities right now have economic situations where in Detroit they used to rely on the car manufacturing industry, which in the United States is tanking, and so Detroit is a shrinking city. Whereas San Jose, their industry is largely based on technology. It's near the Silicon Valley. They've got lots of technology going on there, and so it is a growing city. So, a couple things you can tell. In San Jose, 1 plus R is right now 0.0064. So what would R be by itself? What would you have to do to both sides of that? So what's in the parentheses is 1 plus R. Okay, you're going to minus 1 from both sides. So the R for San Jose is 0.0064, which is 0.64%. Okay, remember with percentages, you move the decimal 2 places. So that's in San Jose. So he's right. It is a growing city. Its growth rate is 0.64. Whereas Detroit, its 1 plus R is 0.9858 right now. If I minus 1 to both sides of that, I get a negative number. And I get negative 0.0142. And if you move the decimal on that, that's negative 1.42%. Okay, so you've got San Jose is showing a growth rate, whereas Detroit is showing a decay rate. What else can you tell me, a fact, just by looking at that? Marcus? Okay, Detroit is decreasing faster than San Jose is growing. Okay, another fact.
Detroit started bigger.
Okay, Detroit's starting population was over 1 million, wasn't it? 1.203368 million, whereas San Jose started. So what will eventually happen? Detroit starts with a larger population than San Jose, but San Jose has a bigger growth rate than Detroit. Okay, not even just meet.
Oh, they'll pass.
They'll pass each other eventually. Okay, so you can tell that just by looking at the equation. You don't have to do a lot of math. I did a little subtracting, but not a whole lot. Okay, let's try another one. It is going to, but not much. Okay. All right, 100 bacteria, double, each hour. Write a model. And another word for model is equation. All right, 100 bacteria, double each hour, write a model. All right, so I'll start this one out for you. So P equals, we want to start with P sub 0, which is the original amount of bacteria that we have, which would be 100. 1 plus, now how do we show that something doubles? Okay, is it 1 plus 2? Is that a double? Okay, what does this mean? Okay, I'm not sure either, that's why I'm asking.
Because, well, the rate is actually double, so that would be the rate, right? But then you'd have to add 1 to that.
It's like, yeah, it should be,
But then it'd be 3, so that doesn't
Okay, you're going to add 100%.
yeah.
Okay, to double means you are taking what you have and you're adding exactly a full 100% of it, which will double it. So it's 1 plus 100%. That's how you double something. Okay, T, we don't have a specific time, but we know that the cycle is an hour. So that's 1. Okay, it's not like the cycle is 2 hours or 4 hours. Right now the cycle is 1 hour. So that's our model. Now we can clean that up. So P is 100. Now if you move the decimal on 100%, you just get 1 plus 1 to the T. So P is 100 to the 2T. So that's our model right now. Okay, now the question you might be asked as a follow-up, how long until there are 350,000, so 350, I'll put my commas, bacteria. So where do I put the 350,000? Where the P is. So 350,000 is equal to the model of 100 times 2 to the T. And now I'm going to do some math on both sides. So what should I do first? Okay, divide by 100. There's zeros and everything, so a couple of the zeros reduce out, so I get 3,500, and I'm left with 2 to the T now. What does this mean? Okay, what kind of log? Natural. Okay, I want to do a natural log in front of the 3,500. I also want to do a natural log in front of the 2 to the T so that, and Ryan was doing this with his fingers, so that, okay, what does it mean though? Why would you do it? I want to bring the T out to the front, right? And so I'm going to have 3,500 with the T in front of the ln2. And then my last step is going to be to divide away the ln2. And so T is going to be 3,500 divided by the ln of 2. Now be careful, ln's don't cancel out. Okay, don't just cross out the ln's. What's the only thing that cancels out an ln? Right, not another ln. Okay, 2 ln's do not cancel each other out. But you can use your calculator. Okay, Ryan, I don't have mine out, so you can tell me what that is?
15.095.
15.095 what?
Hours.
Hours. Okay, correct. Right, you wonder how bacteria can grow so quickly? Okay, it's doubling every hour. And so in only 15 hours, we'll go from 100 bacteria to 350,000 bacteria. Okay, so you leave something out and it grows all of that bacteria right away. Okay, here's our last example. That was an example from biology. Here's an example from chemistry. Okay, 6 grams of a chemical. All right, 6 grams have a half-life. Half-life is a decay of 20 days. Write the model for the equation. Okay, that means it goes down by half. Instead of doubling, it goes down. That's what a half-life is. It's decaying. All right, so our model for this is going to start with P equals. The 6 is the original. And this will be 1 minus, because it's a decay. And it's decaying by how much? Percentage? 50%. Okay, so 1 minus 50% to the time divided by, and how long is this cycle? That's where my 20 comes in. It wasn't just 1 hour or 1 day, it was 20. And so we have 6 times 1 minus 50% is 0.5 to the T over 20. So then you can be asked a follow-up question after you write the model. How long until only 1 gram is left? So where will we put the 1? In for P. So 1 equals 6 times parentheses 0.5 to the T over the 20. And my first step on both sides would be to do what? Divide by 6. So 1/6 equals 0.5 to the T over 20. My second step would be to apply a natural log in the front of both sides. So my natural log of 1/6 in front of the natural log of 0.5 of T to the 20. And I do that so I can pull both the T and the 20 to the front. So that will give me the natural log of 1/6 equals T over 120 in front of the natural log of 0.5. And now I need to work on getting my T by itself. So now what do I want to do to both sides to get one step closer so that t is alone? Multiply by 20. Okay, so that'll make 20 in front. So that will give me 20 in front of the ln 1/6. And it leaves me with just t in front of the ln 0.5. So then my last step would be to divide. So t would be that 20 multiplied by the ln 1/6 divided by the ln of 0.5. And again, those ln's don't cancel out. They just work through on division. Got that one already?
Yeah,
Okay.
51.700.
Can you say that again?
51.700 days.
Not days. Or did I say, did it? Oh yeah, days. I'm sorry. You're right. Okay, so that means if you left this chemical sitting around, in 20 days, half of it would be gone. If you waited at 51.7 days, you'd get down to 1 gram being remaining of what you had. Okay, that's a decaying isotope. All right, so the homework tonight is on how things grow and decay. So either population, or maybe bacteria, which is a population, or maybe some grams of chemicals. Okay, homework help is tomorrow morning if you need it. And next week we only have 2 more lessons to finish up this semester.